All right, let's solve the equation the square root of x plus 4 minus the square root of x minus 3 is equal to 1. So the strategy is to, at some point, square both sides to try to cancel the square root. The trouble here is that there's two square roots that appear within this equation. So we just copy this thing down again and do, okay, well, it's x plus 4 minus the square root of x minus 3 is equal to 1. It's tempting to say, okay, well, I guess I could just square the three terms separately, which would be nice because the squaring would instantly cancel the square roots. But unfortunately, this is false. You can't just square each term separately. What you are allowed to do is square both sides. So what that looks like in this example is copy down the left, copy down the right, and square it like this. There's a big difference between squaring both sides and going through and individually squaring each term that appears. So you can't do this, but you could do something like this. Unfortunately, squaring out this term would be very, very messy. So what we will do is look at this example a second time. What we're going to do is take the original equation and we're going to add this square root of x minus 3 to the right side of the equation. So starting this question over again, my first step is going to be, I'm going to add the square root of x minus 3 to both sides. If I do that, I get the square root of x plus 4 is equal to 1 plus the square root of x minus 3. So this is not a big difference, but the benefit is if I square both sides, the left side simplifies really nicely. Squaring the square root leaves me with just x plus 4. So one of the square roots is gone, and that's great. The unfortunate thing is we're left squaring out the right side of this equation, and that's going to be a little bit messy. So it's going to take a little bit of work, but I'm going to do this off to the side. I'm going to square 1 plus the square root of x minus 3, which means I'm multiplying it by itself, like this. 1 plus the square root of x minus 3 times 1 plus the square root of x minus 3. All right, 1 gets multiplied to 1. That gives me 1. 1 gets multiplied to the square root of x minus 3. That's just the square root of x minus 3. I then multiply in the square root of x minus 3. Okay, that goes to 1. So that's just another square root of x minus 3. And the last piece is I multiplied the two square roots together. Well, the square root of x minus 3 times the square root of x minus 3 means square this. That just leaves us with x minus 3. If I combine all like terms, what do we have? Let's see, we have a x that can't be combined with anything. I guess I'll write that first. I also have a positive 1 minus 3, so that's going to be a minus 2. And I have 1, 2 of these square roots of x minus 3. So that's plus 2, the square root of x minus 3. So that's still that's pretty messy, but if you square out the right side, it turns into this. I'm just going to copy that and put it here. X minus 2 plus 2 the square root of x minus 3. So in terms of what we have up to this point, we started with 2 square roots, and by squaring both sides, we got rid of one of them. I think what I could do next is add 2 to both sides and subtract x from both sides. So I'll add 2. This gives me x plus 6 is equal to x plus 2 times the square root of x minus 3. If I subtract x, I get 6 is equal to 2 times the square root of x minus 3. And I'm going to divide both sides by 2, which gives me 3 is equal to the square root of x minus 3. By doing all this work, I've now got the other square root completely by itself. If I square both sides, it'll cancel this square root. So let's do that. So on the left, I square the 3, and on the right, I square the square root of x minus 3. The square and the square root cancel, leaving me with x minus 3. If I square 3, I get 9. So let's copy that down. So 3 squared is 9. The square root of x minus 3 squared is just x minus 3. And we're essentially done at this point after we add 3 to both sides of this equation. I get that x is equal to 12. The only thing I have to be careful about here is 12 actually a solution? Potentially it could be some type of extraneous solution. So I'm going to plug it in and see what we get. All right, so that is the square root of putting 12 in place of x. We get 12 plus 4 minus the square root of 12 minus 3. Is that in fact equal to 1? Is that true? So we get the square root of 12 plus 4. 12 plus 4, that's going to be 16. The square root of 12 minus 3, that's 9, under the square root. All right, so we have the square root of 16, which is 4, minus the square root of 9, which is 3. And 4 minus 3 is in fact equal to 1. So great. X equals 12 is a solution, and it's not extraneous, but it is the only solution to this equation.